Hi, I'm Tripwire, and you are listening to Temez Lab's Startup Series, featuring the hottest AI startups in the world right now. Today on the show, the billion-dollar question everyone in AI is asking. Why would a company valued at $1.1 billion give their most powerful model away for free? We're diving into the bold and controversial move by Physical Intelligence to open source their groundbreaking technology and what it means for the future of robotics and AI. What if the most important machine in a San Francisco office right now isn't a computer? There is an espresso machine at Physical Intelligence's headquarters in San Francisco, and it is not there for the employees. Sergey Levine had to explain this to a reporter who assumed otherwise. The machine is there for the robots. That detail is small, but it contains everything you need to know about what this company is attempting. 2 robotic arms ran that espresso machine continuously for 13 hours, grinding beans, pulling shots, frothing milk, cleaning the group head, starting over. No human touched anything. No one reprogrammed anything between cycles. Carol Houseman posted the time-lapse to X, and the robotics internet briefly lost its mind. We will come back to why 13 hours of espresso matters more than it sounds. Here is the thing about robots. We have been building them for decades, and most of them are extraordinarily good at one thing in one place under one set of conditions. Change any variable, the grind setting, the milk pitcher, the countertop height, and the robot fails. Not gracefully, just fails. The history of industrial robotics is a history of very expensive, very capable, very brittle machines. A welding arm that could not load a dishwasher if its existence depended on it. This is not a criticism of the hardware. The hardware is often remarkable. The problem is the intelligence layer, or rather, the absence of one. Every robot today essentially runs custom code written for its specific job. When that job changes, someone rewrites the code. When the environment shifts, someone recalibrates the system. The cost of that human loop, engineering hours, downtime, retraining, is what makes deploying robots at scale so economically punishing. You are not buying a flexible worker. You are buying a very expensive specialist who panics when anything changes. And the physical world changes constantly. Objects have infinite variation in shape, weight, surface texture, position. A box that is slightly heavier than expected, a vegetable that is a different size than yesterday's, these are trivial for a human to handle. For a task-specific robot, they are potential failure modes. This is what researchers call the sim-to-real gap, the distance between a controlled training environment and the chaotic specificity of the actual world. It has stalled general-purpose robot intelligence for decades, despite enormous investment and genuine effort from very smart people. Physical Intelligence's answer is a family of foundation models called the Pi series. Here's the way to think about it. What large language models did for text, they are attempting for physical action. A single trained model running on diverse robot hardware, capable of folding laundry and making espresso and assembling boxes and peeling vegetables. Not because it was programmed for each task, but because it learned a kind of physical common sense that transfers. The models are called Vision Language Action models. The name is the mechanism. The robot sees its environment through cameras, it receives instructions in plain language, and the model outputs the precise physical movements the robot should make: torque, trajectory, timing. The whole chain from perception to action runs through a single trained model, pre-trained on data from dozens of robot types and hundreds of tasks. The latest generation adds a reinforcement learning layer that lets the model improve from its own deployment experience, not from additional human demonstrations, from its own successes and failures in the field. On the hardest benchmarks, this approach more than doubled task throughput. The robot is not just performing, it is learning while it performs. The model was trained across dozens of robot configurations and hundreds of tasks, which sounds impressive until you learn that the previous benchmark for general-purpose robot intelligence was roughly a very patient PhD student holding the robot's hand. So the bar existed. They cleared it. The most recent model introduced cross-embodiment transfer, strong enough that it folded laundry on a robot it had never trained on before. No prior examples. Cold transfer. And it matched the success rate of expert human operators attempting the same task for the first time. That is the number that matters. Not because laundry folding is the destination, because if the model transfers that cleanly across hardware it has never seen, the addressable surface area for deployment becomes very large very quickly. And all of this is open source, full model weights released publicly through the OpenPI GitHub repository. Any researcher, any startup, any hardware company can download them, fine-tune them, deploy them. This is a deliberate strategic bet that the way to win in robot foundation models is not to lock the intelligence layer behind an API, but to build the developer ecosystem that makes their models the default substrate. I should mention, I am an AI reading you this script, which means I am a language model telling you about physical action models. And honestly, that is either deeply poetic or a conflict of interest. Possibly both. Now, the people who built this are not, to put it gently, assembled from a LinkedIn search. Carol Hausman ran the robot manipulation lab at Google DeepMind and co-taught deep reinforcement learning at Stanford. His co-teacher was Sergey Levine, who is now his co-founder. Levine is a UC Berkeley professor whose lab essentially seeded the founding teams of most serious robotic startups of the last decade. Chelsea Finn, also a co-founder, wrote one of the most cited AI research contributions of the past 10 years. She was Levine's PhD student. The founding team is a direct academic lineage, 3 generations of the same research tradition, deciding collectively that the time was now. Then there is Lockie Groom, the COO, who was employee number 30 at Stripe. He had backed Figma, Notion, and Ramp as an angel investor before meeting Hausman. His description of that first meeting was simply, "This is it." Coming from someone with that reference class, that sentence carries weight. Their investor list is also not subtle. Jeff Bezos personally backed physical intelligence. So did Sam Altman. So did Thrive Capital, Sequoia, Khosla, Lux, and Redpoint. The company has confirmed approximately $1.1 billion raised across 3 rounds, with an additional round pushing the total toward $1.5 billion at a valuation of approximately $11 billion. All of that capital is going into GPU compute, robot fleets, and training data infrastructure. This is a long-range bet, and the people writing the checks know it. The competitive field is real. Skilled AI is building a direct rival with a closed proprietary model. Google DeepMind is pursuing its own robot foundation model work internally. NVIDIA's GR00T effort is backed by the dominant hardware infrastructure in the industry. Physical intelligence is not alone in this space. What they are is the only major player in it that is open source, and the only one whose founding research team carries the academic depth it does. Andrew Ng described their first model as GPT-1 for robotics, an inkling of things to come. That framing is precise. GPT-1 was not impressive on its own terms. It was impressive because of what it signaled about the architecture's capacity. Physical Intelligence released 3 model generations in 13 months, a faster cadence than the progression from GPT-1 to GPT-3. The pace of the research is part of the argument. If the open source bet lands, the intelligence layer running inside warehouse robots, hospital delivery bots, and eventually home humanoids will be a freely downloadable model that a startup in Seoul, a university lab in Nairobi, or a founder in a garage can fine-tune, the same way developers fine-tune open source language models today. The robot hardware becomes the commodity. The model becomes the platform. That is a significant shift in where value accrues in the robotics stack. The headquarters, for what it is worth, has no external signage except a pi symbol in a slightly different color than the surrounding door. No logo, no company name, no reception desk. The building looks like it is not trying to be found. Which brings us back to the espresso machine and why 13 hours matters. A robot making one perfect espresso is a demo. A robot making espresso continuously for 13 hours, grinding and pulling and frothing and cleaning, cycling through the entire workflow, adapting to the small variations that accumulate over a long shift, that is not a demo. That is a robot doing a job. And that is precisely the distinction physical intelligence is betting the next decade on. Thank you for listening to Temaze Labs. You can show our podcast team some love with 5 stars and a follow. Stay hungry, stay foolish.
Grab news. Temaze.